Projectile motion series M&M quiz 2173. Welcome to hecanhelp.com. Welcome. At t is equal to 0 seconds, a projectile is launched from point A as shown at 22 meters per second magnitude and 30 degrees with respect to the horizontal. Assume no air resistance and constant acceleration. Assume change in y from A to C. Change in y from A to C is equal to 0. Question: what is the vertical velocity component at point C? Is it A, or is it B, or is it C, or is it D? Let's say if this is the x component, what do you expect is the y component? On the way up, the vertical component decreases. On the way down, vertical component increases. So what happens if you are at the same height? It should come back to the same number as we started with along the vertical. So if we start with 11 as the initial component of the velocity vector, then on the way back at the same height, we should expect a magnitude of 11 but a direction of negative y. So your answer should be negative 11. Your y component should be negative 11. So you want to know the time to go from A to C. So we want to get the time to go from A to C. Why? Because acceleration on the vertical is given, and that is equal to change of the vertical component divided by time. To get the time, you use delta y is equal to v0y times time plus 1/2 acceleration along the vertical times time squared. Initial velocity along the vertical, what is that? 22 sine 30, and that is 11 meters per second. Time is the time to go from A to C. We don't know that. What is the acceleration along the vertical? It is negative 9.8 meters per second. What is change in y as you go from A to C? Change in y as you go from A to C is 0 because points A and C are at the same vertical height. So because of that reason, we can get delta y, we can make delta y equal to 0. So delta y is equal to 0. So initial velocity along the vertical 11 times time plus 1/2 acceleration along the vertical, negative 9.8 times time squared. Now you cancel time by dividing throughout by time, and you get 0 equals 11 plus 1/2 negative 9.8 times time, from which you get time is equal to 2.245 seconds. So time to go from A to C is 2.245 seconds. Once we have the time to go from A to C, then we can determine what the final vertical component of the velocity vector is. From acceleration along the vertical is equal to change of vertical velocity components divided by time, we get the final vertical component equals initial vertical component plus acceleration along the vertical times time. What is point A? It is the initial point. What is point C? The final point. So we have the initial point and the final point, and we know the acceleration along the vertical, negative 9.8 meters per second. What is the initial component of the velocity vector? It is 11 meters per second. Remember, it is 22 sine 30, and that is 11. So we have the vertical component at the start. We want to know what is the vertical component at the end. We now know the time 2.245 seconds. Substitute into v final y. V final y is equal to v initial y plus acceleration along y times time. V initial y is 11. Acceleration along y is negative 9.8. Time is 2.245 seconds. And when you do that, you get negative 11. And that is as expected. So many meters per second. And this is George Mathew, always pushing you to the next step. Bye.